Welcome to the Todd and Noah Show.
Nice to be here.
Taking the mystery out of electric motors.
Sounds a little mysterious.
Sounds very mysterious. We've been we've done quite a few podcasts and talked about so many different types of electric motor testing and gone to many different trade shows, and we talk about that. We get questions asked to us, and what's the next phase in this? What's the next avenue of electric motors? What's on the horizon? And we could ask the same question about, I want to monitor my motors 24 hours a day, 7 days a week.
It is. It's a growing interest. It's been there for a while. It's been sort of creeping up in the vibration side of the industry. It's now expanding out to all technologies, and we've talked about the onset of the pandemic has really kind of created a vertical launch on that, because people had a difficult time getting to the sites and getting their hands in on the motors and taking the data. Where if they had some permanently technology installed on these critical assets, they could look at that data 24 hours a day.
So if we were to look at a piece of technology and we were to say, we need it that's going to do 24 hours testing, what are some of those parameters that you would say this is necessary in this type of, if we're going to do this type of testing? So naturally, 24 hours a day, 7 days a week, that's a given.
It has to be the primary. And the fact that you are going from, we kind of compare it to like walking to riding a bike, or imagine if you had to walk 10 miles to school or whatever, and then someone gave you a bike. It's a miracle, right? It's so much more. We're talking, a test frequency of quarterly or twice a year, and now we're giving it to you every minute of every day. It's an amazing jump in data and having access to knowledge and information. So absolutely, the reliability of the asset has to be the first decision-making variable in mind when you decide, hey, I'm going to go permanently install. Closely behind that is resources. Is finding good people, those who haven't already retired, or new kids coming out of college that are interested in maintenance reliability.
The lack of resources is almost driving this decision making into continuous monitoring.
It is.
Location, if you're at a pumping station miles away from your offices and it's difficult to get people out there, that might drive a decision.
Well, here's a good example. You've got key players in your maintenance reliability department, and you have a motor that's tripping on the other side of the plant, and that's an important process to be up and running. And you also need to collect data. You need to test data on these motors that are operating fine. Where do you send your resource? It's never to go get test data, right? And so you end up sending your resources to the troubleshooting side and doing what is critical, putting the fire out. And you miss a lot of the testing, right? So with those resource limitations, it's inevitable that you're going to miss a lot of reliability testing that's important. So if you can give that time back to the resource that you're struggling with, it's one less thing you have to worry about.
So 24 hours a day, that's a given. 7 days a week, you always want that data to be there. You don't want to have to rely on quarterly tests, especially if there's an issue. So next, you always say this, I want to be able to see every inrush. Well, now you should be able to if you have a piece of equipment set up.
For me, as you know, the inrush startup is my favorite test, right? And it's so inclusive of different, fault zones. Almost every fault zone can be incorporated into the inrush startup. I will insulation to ground, not so much so, but almost every other fault zone can be analyzed through that test. So it is a critical test to me. If I know I'm over there, connecting a new motor or troubleshooting a boiler feed pump or monitoring a switchgear operation or whatever, and I know a motor's going to start, but I can't get that inrush, it would hurt me, right, mentally. And so, but knowing that I have the ability to, hey, when that motor starts up, next time at the office, I just go look at the inrush startup test. It's so telling. And so, absolutely, I put that very high on the spectrum of importance when it comes to making decisions on permanently installed technology, is not missing an inrush startup.
As well as monitoring the number of starts and stops, because there's a given number per motor, as you'd mentioned.
We spend a lot of time with motor manufacturers reviewing their design criteria area. For the average motor, you hear this a lot about 3,000 starts for the life of the motor. Now there are certainly motors designed to exceed that, right? And that's depending on what they build into it, how much steel and how much mass and that kind of stuff. Temperature control is a big deal. But 3,000 is a magical number, and if you knew you were on start number 2,900, it would be nice, right? And so that's one of those things that we definitely want to keep track of.
Also, if you have if you have high voltage, you're not really allowed to start those back to back, are you?
Good point. Now, there are requirements, there are standards in place. NEMA gets involved in this a little bit. Manufacturers should be consulted. Some companies get ahead of this and they actually build those limits. Like if you're not supposed to start more than, once in any given hour, there's time between starts and then there's time starts per hour, per se. But once you know those limits, you can build them into the regulation relays or the relays and actually prevent that. But a lot of companies don't have that, all right? So you want to be able to know, when you hear these horror stories like, from operations, and these guys don't necessarily know, what makes a motor turn or run or last longer. But when you start hearing things like, I noticed that if I turn it off and start it again, it runs better. What does that mean? That's not according to the standards,
Good practice.
It's not good practice. He may not know that, and if he doesn't have something in place to relay limit him to do that, then this is abusive, and he needs to be educated that, hey, we can't do that. If there's a problem getting this motor started, maybe we should look at the rotor bars, or maybe we should look at the voltage being fed to the motor, or maybe it's designed wrong, maybe they've wound it incorrectly.
So another thing that we would want is if you're going to incorporate this type of testing, it should be seamless with your existing testing, right? So if you're already out there with portable test equipment and you're collecting data, you would also want, if you're going to collect 24-hour data, you would want that information to be seamless into the same software program as the portable, would you not? You
would. And you know what, to add to that, it's like, if you're already resource limited, and you have to send these guys to training. You have to get them trained on this or get them trained on that. There is a point where, initially we're like, hey, let's just keep our data to ourselves and stuff but the reality is, when you're dealing with, limited resources in ultrasonics and motor testing and vibration and thermography and oil analysis, that's a lot of training. It's a lot of expertise. There is a point.
You got to learn the software.
Yes, and if you have to learn the software just to be effective, and it's just a lot going on. If you can deploy programs that actually that information can fit right into an existing dashboard. It's huge. And so ask a lot of questions. When you're deploying technology, it's like, hey, how do I get that into a centralized dashboard so that I don't have to you can have analysts that don't even have to relearn your specific software. They can just be relying on the dashboard that they're working with.
In keeping in line with the software, you also want it to be kind of accessible from anywhere. So maybe cloud is key for this.
Yes, it is. And I'll tell you, cloud brings up a cybersecurity question. It's inevitable. It's there. We know it exists. There's things to be concerned about that, and we're getting really good at filling out those questionnaires. But cloud is such a huge tool, and we're even seeing, there's still some companies, some organizations, sometimes they're military or government, that they're not real friendly towards cloud, but that's changing. As they come up with ways of maintaining security and keeping it secure, the cloud is just hard to ignore because it centralizes stuff and it makes it accessible anywhere. The days of installing software to operate and look at data and be an analyst are a thing of the past. The phrases they use now are portable software. Literally all you have to do is access files and that gets you into the data. You can be anywhere, anytime. You can be at the sunny Tampa, Florida on the beach visiting PDMA during a training class and you're just walk to the hotel away from getting on and helping your plant analyze some motor data. Maybe that's not so good, but either way we have it. So I would say the cloud is kind of in that same, it's not even early innovative, it's the early majority. And but if you're in a company that's a little reluctant, just make sure IT's involved and get the security questions answered and take advantage of that tool that is so helpful.
Yeah, and keeping kind of in line with the software and the cloud, it's having your key performance indicators or your KPIs being able to get integrated into the decision-making software.
Absolutely, and we hear everything from Pi to CMMS to asset management software. What ends up happening is, a lot of times someone is looking at a whole plethora of information, and so, we've done a lot of work, and you and I have been to trade shows, around the country, around the world, and one of the common conversations, and this is early innovative now, is people want these KPIs to be incorporated into a Pi program for asset or machine train learning, or an AI program. And I'm not a huge fan of just purely AI without a lot of human interaction. We've seen that too many times, and we've got case studies on that. But PDMA and other companies spending a lot of time working on these APIs. We're talking about, everyone has their slight different one, but that toolkit that we can provide a company that has this centralized dashboard technology. So when the maintenance, we've seen stuff like M&D centers where they pull experts in from different places and they sit there and they monitor all this data on a centralized dashboard communication. It's KPIs, and I can't say enough about how effective that can be. The problem with permanently installed technology that we have to be aware of is make sure we don't fall trap to the whole nuisance alarm and you start to ignore it. We wrote an article, recently about installed technology that, they had turned off the alarms because they were sure that they had a CT failure. Well, they had a big current imbalance, right? And that's bad as it is, but what they thought was for sure they had a bad CT, so it's just not a legitimate imbalance. Well, somebody that came through to audit their maintenance program said, hey, why are these alarms turned off? And they said, oh, we got a bad CT, we haven't replaced it yet. And he says, well, how does that explain the 2 high temperatures on the phases, that were also turned off? Yeah. So, but they weren't combined in a centralized area. So someone's saying, hey, we got a phase alarm on temperature. Oh, and you've got a current imbalance alarm, which you think is nuisance, but it's not. Permanently installed technology should not result in ignoring. It cannot. It has to be focused on. So yeah, I think that, we've done our homework and other companies done their homework. When you're looking at installed technology, if you have centralized dashboard technology for analysis, make sure that they're providing a toolkit to get that integrated in.
And then for the technician or whoever is collecting this information, you almost need something that if you have an event occur, it needs to come to you almost immediately on your cell phone or somehow it needs to get to you.
Right.
Cell phone is preferable.
Absolutely.
Everybody's carrying one with them.
Yeah, my opinion is, mobile is a solution. And, with 4 kids, mobile phones were always an aggravation for me, and it was a good weapon for improving attitude, right? If you needed improved attitude, yank a phone out of their hand, you'd be surprised how quick you get a response. So, but now that I'm in the reliability industry and I see the big benefit, everyone has a phone, it's just part of our day-to-day. But if I can get a beep and it says, hey, I've got a fault zone event on the stator or a rotor of a critical motor, I am made aware immediately that something's going on, right? And there's different levels. Like if I'm an analyst, I need to know the details, right? And I can get some details on the phone, then I can go to a computer and get even more.
Not only a computer, because it's cloud-based, you can go to anywhere. You can go to McDonald's, you can go to anywhere that has a Wi-Fi, because once you get the announcement that there's a problem, you can call the facility. If you're out fishing, let's say.
Absolutely.
You call the facility, tell them, hey, there's something going on with this asset. Is there something different? And then if you need to take a better look at it, you can go anywhere.
Right, and and there's automated machine learning fault zone analysis. So you're going to get an alert that a machine logic said, hey, this just went into fault zone. Yeah. You as an analyst are going to take it another level, and we always say, hey, let's make sure we save an asset health assessment to a human being, right? So I want an analyst to look at the machine learning, fault zone alarm, look at the details, and I want that human being to actually go from normal to caution, right? Now look at yourself, let's say that you're a motor owner. You're not a motor expert, you're not an electrical engineer, you're not a technician that knows what this data means.
Nobody.
But you own the motor, so you're a somebody, right?
I am somebody.
Do you want to know when there's a high pole pass frequency and you had to start opening up Google to try to figure out what a pole pass frequency is? Or do you want to know when your guru analyst decided that this motor's in a position that I went from normal to caution. Now, as an owner, you're like, hey, what's going on? And he's like, well, I think there's a rotor problem, right? He can give you a description. You don't necessarily need to look at data and try to understand what's going on. So having different levels of alarms, one that you recognize for an analyst comes from an automated machine learning, logic, and then another level, more of a management level, that says, hey, experts have looked at the data and they've assessed it as a caution, right? I think that's a critical piece of communication. So when you guys get together for the weekly stand-up meeting or whatever from maintenance and reliability, management knows what's going on, you got the details, you can tap right into the cloud, the database, and start looking at if they want more detail, they have it.
Yeah. And then almost kind of the last kind of piece of the puzzle is you want to make sure that the information that is being provided, you can digest it. Because there's a lot. When you're talking about continuous monitoring, you're talking about continuous data being flowed in, and you want to be able to easily and, really easy to digest that information and determine what's actually happening. So can you explain a little bit about that?
I can tell you my whole approach to data analysis with permanently installed technology has changed. And the reason I say that is, historically I'm opening up history charts, looking at data, maybe 3 months old, maybe 6 months old, but I'm trying to assess, what's been going on. What was the previous test, this kind of thing. With permanently installed technology, I go from a history chart analysis to a historian, right? Now we're talking minute by minute data, similar to someone like yourself maybe looking at your financial portfolio on an investment, where you're looking at the ups and downs, the highs and the lows. Imagine having that moment-to-moment data on KPIs related to your motor. It changes everything. I can quickly go in there, look at the last 24 hours, the last week, the last month, quickly determine whether anything's changing. And it's so fast I can determine, move on. I don't need to spend any time on a motor that's been perfectly the same. You can look at voltage imbalance, voltage values, current imbalance, impedance imbalance, pole pass amplitudes, starts and stops. That is such powerful data, and it makes my analysis so much more efficient. When I get an alert from machine learning logic, I can go and look at the historian.
Or it exceeds the KPI that we've identified.
Exceeds the value, right? I can look at that historian. Was it something that just happened? Has it been creeping up over the last couple of weeks? It allows me to know whether I need to stop what I'm doing and go attack that, or whether it's something that it may ended up being something like it's here and gone, and it may have been. Like one of the things we worry about is, catching a motor on a test that's going through a transient, right? When its current's on or off. The more logic we get, the better we should be able to make decisions that that's an off versus just an actual anomaly. But that's if you see something happened and there's no trend at all, it means something very different than if it's been creeping up for the last week or two.
Yeah, well, having that, like I said, there's a lot of data. You have to be able to digest that data, and it can't just be just numbers thrown at you. You need to have cautions and alarms and things. So we wouldn't be PDMA, it wouldn't be
who we are
as a company if we didn't support what we're talking about without a case study. Because you can listen to Noah, or you can listen to myself, but we always like to back up what we say by sharing with them customer actual real life situations, and in this case it's no different. It's installing a continuous 24 hours a day, 7 days a week monitoring system on a pump motor.
Out in the middle of nowhere.
Out in the middle of nowhere, so this is kind of in line with what we were saying. And out of the gate, we put it on this motor that had a potential issue.
Yeah, part of me says what's interesting about this whole thing when you're assessing companies to qualify for a beta trial on permanently installed technology. What's a person going to do? If you're a motor owner and you've got these places that you're sending people in trucks out in the middle of nowhere on a regular basis to get data, verify these super critical pumping stations are up and running. Why don't you pick those? And if there's ever been a concern at all, let's pick that one. So, we installed these devices, they were of course in the middle of nowhere, so it was all cellular capability. They didn't want to tap into the operations network. That was top secret, I like to call it. So it was all cellular, and out in the middle of nowhere, we installed it onto 2 pumps, and so it was a great case study.
So then we saw one that had some issues with the rotor bar. Now, normally, if we were just doing portable type of testing, we'd say, okay, we need to increase the frequency of monitoring. So that may go from every 6 months.
Twice a year to every 3 months.
Quarterly.
And that's not to say
to
that
monthly.
Right,
but
we
if
have
it's in the middle of nowhere, that's a no-go.
It's
That's
a
not
no-go.
going to happen.
Nope.
So now you have the capacity to monitor this.
Right. They may have made a decision to replace that motor with just the first round of data because it's too critical not to, right? But when they had the ability to look at it every minute of every day.
Well, we mentioned this a little bit earlier. You have now the knowledge which provides you the comfort level to know that is this rotor bar degrading quickly?
Right.
Is it degrading not as quickly? Now we can do some things. We can limit the starts and stop because we know that's the most dangerous time of the motor is at startup, the most stressful time. So we can start to limit that. We can limit load shifting on it. We can limit some things to this motor.
Absolutely.
Knowing that we're checking it every day, we're looking at that, and then we determine when that should be pulled for further evaluation at a repair facility.
Yeah, it really is. It's reliability 101, and the comfort of making that decision based on trend is so much better.
Yeah, so in this case here, we saw some pole pass sidebands. We saw fifth harmonic activity, or swirl,
We did.
as you call it.
Yep.
And we have time domain, and that's, you had mentioned this, you've said this numerous times, 3 strikes.
It's true, and Texas Port hates to make a call on a rotor without at least 3 indications. And you've heard some of our past discussions where we talked about a C story where I had the pulverizer motor completely trick me that we had rotor bar problems until I saw the same frequency on all 4 pulverizers and realized that it's something else. Well, it was a machine learn. It was a machine, a standard mechanical frequency that just happened to coincide with pole pass, misled us, right? So, but if you look at 3 different indications, like in this situation, I know we had, like you mentioned, pole pass sidebands, we had the 5th harmonic, we had the elevated demod in pole pass frequency. Everything lined up to say, hey, this is a legitimate problem. If they wanted to go further, they could, because they saw the trend wasn't rapid, it was going up slow. If they wanted to send somebody out on a timely schedule with a portable technology to re-verify it, they could have, and had time to do that. They had reason.
Well, the best part is, like they said, they were comfort, they could see the trend, and they could determine when to make the fix.
Right.
When operationally it made sense to make this change, replacement, or fix. And in this case here, it's a pretty large motor, so you want to be sure it's 2,000 horsepower.
Yeah.
And so you want to make sure of what's happening before you decide to really pull this and send it out.
To get the team out there, to do the deconstruction, to get it on a truck, to get it shipped in. It's a lot of work. You just don't want to make the wrong call.
They trended it over time, and they were watching this as it went on, and then they, rather than take any more risk, they decided to pull it and sent it off, and the motor shop replied. They just wanted to send a message back saying the 2,000 horsepower motor we currently have in the shop. We're in the process of checking all the mechanical fits, but I wanted to advise that we have confirmed the rotor has quantity 5 broken rotor bars, and they attached the pictures of them.
Right, we'll have to describe that picture to the crowd here. What's interesting
They're all
is
in the same location, kind of.
they are,
So,
right? And what's interesting, you've heard us talk a lot about, if you hear the rotor discussion or whatever, that rotor design is important. Is it an open bar where the rotor bar can come out, or is it a closed bar where it's going to be sealed down under the iron laminations? In this situation, on the picture, it's wide open. So the bars are open, but what you don't see is a lot of burning of the slots, right? Because if you leave a bar broken long enough, current will basically find a way to travel down the laminations on the open slot, and it'll end up burning open. Eventually the bar will come out into the stator, double the price of the repair. There is none of that apparent, which means that this is fixable. They could do it's not going to be perfect as you might get it from an original manufacturer, but you can weld or whatever, braze the bar,
braze those bars back
to the shorting ring, and get it back in service.
And so they did. I'm not exactly sure what the fix was on this, but they did replace the replacement motor post repair, put it back in, lowered those pull pass sidebands, and now you have you can reset it.
Absolutely.
Reset it, start your baseline again, and move on and look for any potential damage or further as you go down the road. So that was a great case study, and it really kind of shows the power of when you see a problem, how do you address that, and how long can you wait?
Yeah, the advantages of 24-hour monitoring on a critical asset was, you're so right. Just the ability for them to walk into that decision making comfortably, knowing they weren't in a critical situation, but it was a problem. Now, 5 broken bars, people might say, oh my gosh.
Yeah.
But they were early. These were cracks. They were definitely broken, but it wasn't, we're not seeing, secondary damage.
Was it decreasing the speed? We don't know. I don't know if speed, those are the things that are going to tell you, oh, hey, we really need to, the speed is off, so it's much lower speed.
Longer startups. Lower RPMs for the same load, just as you said.
So, now, the next one is a little more interesting just because it's a great understanding of the process that you're with and how continuous monitoring can maybe help give you a better idea of, well, this is a problem or this isn't a problem based on having it on 2 like motors, Sesame Street again.
Yep.
And then if the problem, normally they don't go away, but if it is on, let's say, a conveyor belt or in this case, a raw mill, maybe you can explain us a little bit about raw mill operation.
Right. So if you've ever visited the cement industry, for the service people out there or people who've been in that, it's pretty amazing. They're taking this raw material, rock type material, and they're shoving it into a raw mill. And if you've ever looked at raw mill data from a current voltage perspective, it is not clean. These are constant low variations. This is a very robust operation. A little bit less so on the finish mill, but on the raw mill, it's very rugged. And so, basically you've got a synchronous motor, horizontally mounted, nice size synchronous motor, going into a 90-degree, basically a reduction gear, right? And so it goes to a vertical, the reduction gear comes out, and a vertical goes up into a plate, turns the plate, material's thrown down on this plate, and then there's rollers basically that roll over this material and crush it to a finer material. This stuff goes on and on and on, right? And so having light comparisons was critical. In this situation, we did install it kind of like the pumping station, 2 identical raw mills, so we had that to compare it with, and that was extremely helpful. So that kind of gives you an idea. You've got gears, you've got 2 shafts, you've got rotating equipment, machine trained stuff, and then a big synchronous motor. What's nice is, if you look at some of the data, one thing that we probably tapped the, some of the asset management software for, but, knowing what that gear ratio was critical. Right?
Yeah, and we did a whole podcast on machine train analysis and why it's important to know the gear ratios and speeds, and in this case here the gear ratio is 35-to-1 and it's a synchronous motor, so we know what the speed is. It's 1200 RPM.
That was an easy one.
Whatever the nameplate data said, that's the actual speed, and if you know it's a 35-to-1 gear ratio, then and you know how many rollers there are, well, we can find out on our time domain data or our demodulation data where that RPM would be.
And what was interesting in this specific situation? We knew it was 1200 RPM. We also knew that the output, we were able to get to 35-to-1. We knew the output speed was 33.9, 34 RPM, right? So, but what we found out when we just did calculations, said, hey, we got a peak at 4 times secondary shaft. So knowing how a raw mill is designed, our phone call went to the motor owner basically and said, hey, any chance that there are 4 rolls on this raw mill? And he confirmed there's 4 rolls. Well, that just solidified the fact that peak we're seeing is 4 times the secondary shaft. So the question is, what is hitting all 4 of those rollers? Well, it's the platform itself, right?
Something on that platform.
We quickly assessed that, okay, we've either got a damaged plate, which rolls underneath these rollers, or turns underneath these rollers, or there's some type of material stuck to it, and that was the concern. So, that's kind of what we were able to quickly assess using the demodulation.
And what we quickly assessed is it was stuck to it, and it broke free over time.
Right.
But the beauty of it is, okay, now we know we don't have an issue, but maybe we do. We're going to monitor this further, right? So
build a
we
band
know
alarm.
That this one has constantly getting material stuck, or it's constantly having that extra energy at the 33.
It may have had an imperfection, and that optimizes this kind of situation. I would say for sure the next visual inspection, a lot of times I think they go in there, wash this stuff down to make sure everything's okay, the rollers aren't damaged. This provides information to make those decisions. If it's running like it always has for the last month, last year, why spend any more time on it? You can move on to something that actually is a problem.
Right. So that's another great reason why you would want 24-hour monitoring, because let's say you just came quarterly, you may not have seen it. Or it may have been there and you would have said, put it in a problem and then come back.
Somebody's complaining and you can't see it. It's like,
Or the reverse, you get it, you see it, and then you come back and we haven't seen any problems.
It becomes hard to believe.
Yeah, it's intermittent, and those are the worst words.
There you go.
You're troubleshooting, that's the worst words you want to hear. Oh, it's an intermittent problem.
So true.
So Noah, let's just talk again about the benefits of this installing a 24 continuous monitoring. The 24/7 is without a doubt number one. You want to be able to look at your assets over time, continuously, not have to go out. The pandemic may have driven it. It pushed us further. Supply chain issues, personnel leaving the workforce, not be returning. So those are all things that are driving to the 24-hour monitoring. Always capturing your auto inrush. That's so key. You want to make sure that you're getting the most stressful time of that motor. Every time, how many starts you're getting, how often per hour are they doing starts and stops. Those are very critical components to understand motor health. Seamless addition of software from your MC Gold, any type of software. The data that you're collecting has to be seamless into your other programs so that they all work together, and then when you're going into one platform so that you're not having to open up multiple platforms to look at information. Delivering that information to a cloud-based is key because you want to be able to tap that information from anywhere in the world.
Yep.
Right? Not just locally at your facility, but anywhere, at your house, at your pool, at Starbucks, at Wendy's, at wherever you're going, whatever the situation may present itself. You want to have an alert come to you. Right? I remember you saying you want that alert to come to your phone. That's key. Because without it, you're blind, like you said.
Phone is your friend.
The phone can be your friend, and you're going to run blind on that. And then lastly, or not lastly, but making sure that the KPIs that are being collected are integrating into a decision-making software. Right?
Yep, absolutely.
Those are very key. And then really safety. We've got to talk about safety, but that's really a key component.
It really becomes, especially for those who are trying to justify technology, it becomes an easy conversation that, hey, instead of going out, opening cabinets, doing the testing, which is still going to happen in certain situations.
Well, we know the MTAP is safe because you don't have to open up a cabinet.
Right.
But even now, you don't even have to go drive out to the facility, and you don't have to go into the facility.
Absolutely.
So safety is a big. And then getting all of that information in a digestible format, which you had mentioned is called historian.
The historian approach.
Yeah.
Changed my life.
Approach that changed your life. Well, that's you can't say more than that.
Say no more.
Just say no more. It changed your life. Well, Noah, as always, we appreciate your input into these conversations. Your intellect is greatly appreciated, and. Thank you as the audience, and we hope that you got just a little bit out of today to make your tomorrow more efficient or better. And as always, we thank you, and stay safe and have a great day. And until the next time we talk to you, we'll sign off from here and say goodbye.
Thank you for joining us for this episode of the Todd and Noah Show. We will be back for another episode very soon. In between, we hope to see you in the Mobius Connect online community where you can network, learn, and share with Todd and Noah and other industry professionals at mobiusconnect.com, and we will see you there soon.